Meet Robonaut. NASA's humanoid robot is set to help man explore space. Work on the first Robonaut began in 1997. The idea was to build a humanoid robot that could assist astronauts with tasks where another pair of hands would be helpful, or to venture forth to perform jobs either too dangerous for crew members to risk or too mundane for them to spend time on. The result was Robonaut 1, or R1, a human-like prototype of a robot that could perform maintenance tasks or be mounted on a set of wheels to explore distant destinations. Through 2006, R1 performed in numerous experiments in a variety of laboratory and field test environments, proving that the concept of a robotic assistant was valid. In 2006, the automotive company General Motors expressed interest in the robotic project and proposed to team up with NASA. A Space Act agreement was signed in 2007 to allow GM and NASA to pool resources and work together on the next generation Robonaut. Robonaut 1 was the first model and has been followed by subsequent models leading up to the current Robonaut 2. The core idea behind the Robonaut series is to have a humanoid machine working alongside astronauts. In February 2010, R2 was unveiled, a faster, more dexterous, more technologically advanced humanoid robot than had ever been seen before. The International Space Station is only the first of R2's possible missions. As R2 technology matures, similar robots could be sent deeper into space to test the system in more extreme thermal and radiation conditions. Someday, R2 could serve as communications, weather, and reconnaissance satellites, which have direct benefits on Earth. Robonaut 2 was launched on February 24, 2011, and was delivered to the International Space Station. NASA's experience with R2 will help them understand its capabilities for possible deep space missions. R2's head houses not its brain, but its vision equipment. R2 has 3 degrees of freedom in its neck, allowing it to look left, right, up, or down. Each arm is approximately 2 feet 8 inches long, giving the R2 a total wingspan of 8 feet. Robonaut 2's hands have 12 degrees of freedom, 4 degrees of freedom in the thumb, 3 degrees of freedom each in the index and middle fingers, and 1 each in the ring and pinky fingers. Each finger has a grasping force of 5 pounds. Behind R2's visor are 4 visible light cameras. 2 provide stereo vision for the robot and its operators, and 2 auxiliary cameras. A 5th infrared camera is housed in the mouth area for depth perception. Each arm boasts 7 degrees of freedom and the strength to hold 20 pounds in any pose in Earth's gravity. Here on Earth and at the space station, R2's backpack holds its power conversion system, allowing it basically to be plugged in. On another planetary surface, or on the moon or an asteroid, the backpack would hold the robot's batteries. R2 thinks with its stomach, literally. With its head full of cameras, the only place with enough room for a brain is the robot's torso. R2 operators have several choices for how to control the robot. Station crew members will be able to operate R2 as well as controllers on the ground. However, one of the improvements over the previous Robonaut generation is that R2 doesn't need constant supervision. In anticipation of a future destination in which distance and time delays would make continuous management problematic, R2 was designed to be set to tasks and then carry them through autonomously with periodic status checks. Mobility options for Robonaut are currently being tested. One was a 4-wheeled base, tested during the 2011 RATS, or Research and Technology Studies mission in the Arizona desert. During the past decade, NASA gained significant expertise in building robotic technologies for space applications. NASA's experience with R2 on the space station will help them understand their capabilities for possible deep space missions. These capabilities will help NASA launch a bold new era of space exploration. The next step for robotic capabilities such as R2 would be to explore near-Earth objects, including asteroids and comets, and eventually Mars and Mars moons. The robot will serve as a scout, providing advanced maps and soil samples, and begin work on the infrastructure that astronauts would need. The crew that follows would then be much more prepared for the exploration ahead. Humans and robots exploring our solar system together will provide greater results than either could achieve alone.